Hello and welcome. Welcome to the semi-finals. So we're really excited to hear your pitch. Over to you.
Okay. Hello, my name's Andy Banks and I'm a lead data scientist at the Data Science Campus in ONS. And today we're going to talk to you about Fraud DNA, our project. Why is Fraud DNA important? Every year, tens of billions of pounds are lost to fraud in the public sector. And the vast majority of that is hidden or unknown, and we don't even have a chance of reclaiming that money. Tens of billions of pounds that could be better spent on the government's priorities, supporting the NHS, tackling the cost of living crisis. Our unique toolkit will shine a light on this hidden fraud and support the thousands of civil servants across government that are trying to tackle it. Our tool will help us keep up pace with the cybercrime race. And I'm going to hand over to Sarah now to kick us off.
Hello, my name is Sarah. I work in HMRC, so I know that the scale of fraud in the public sector is immense. Although a small amount of fraud is detected by the government, a huge amount remains hidden, and this is a problem. Why? Because undetected fraud increases the cost of public services, it compromises the ability to deliver services, and it misdirects support intended to go to those who need it most. Ultimately, it is the taxpayer, we, all of us, who bear the final cost of fraud. But Fraud DNA will help detect hidden fraud. The government invests a huge amount in detecting fraud, with 16,000 people working in counter-fraud roles across 45 departments. This reflects the hundreds of schemes that can suffer from fraud. Fraud creates a potential reputational risk to any of these departments because fraud erodes trust, especially if it is facilitated by corruption or is linked to stolen identities with which there is a clear human cost. So we must find a solution to this problem. The more accurately we can detect fraud at an early stage, the more efficient those working in counter-fraud roles can be. And Fraud DNA will help them with this. I'm handing over to James now.
Thank you, Sarah. So hi, I'm James. I work in the Government Consulting Hub, and I'm interested in solving problems across government. And the key problem with fraud is that it is increasingly complex. And so what we see is there are a number of new methods that we need to tackle with fraud, such as the use of deepfake data, which allows the applications to hide from usual detection. Secondly, spam bots. Now they flood caseloads, so it's even harder to spot genuine fraud. And thirdly, stolen identities, and they hide again from detection. So what we see is that current methods within government are too slow and they're not adapting to this new threat. So what we have in this case is that the rate of fraud is going to increase. It's already too high. And that is the key problem that we're trying to solve here. That fraud is hard to detect and it's only going to become harder to detect. And that's why Fraud DNA is so essential. Emdad.
Thank you, James. So I'm Emdad. I'm a curious data scientist at HMRC and who submitted that idea. So what is Fraud DNA? Well, you have to remember, crime is organized and you have networks and relationships with those to create crime. This is just like finding fingerprints and clues in a crime scene. We have these new algorithms out there that have the ability to spot patterns in the network that are hard to see by humans. Our solution will bring together the latest techniques together with clear guidance and a user interface for a tax fraud team. Now imagine you're a fraud investigator. You'll have this easy-to-use interface to ability to select the data and connect data from multiple sources. Once you have selected the data, you'll be able to define the network by using predefined structures or create your own structures by defining the nodes and edges. Lastly, the interesting part, we'll be able to implement known fraudulent DNAs collected from departments, or use graph algorithms to define your own, while prompting the user ethical frameworks. Thank you. I'll hand you over to Stephen.
Hi, I'm Stephen and I work in FCDO as a data analyst. We believe that the toolkit will provide significant benefits which will increase the more it is used across government. The toolkit will highlight previously unknown fraud which will generate large savings. If it helps to recover just 1% of hidden public sector fraud, this equates to £500 million per year. Civil servants working in the counter-fraud function will receive fewer false positive results from automated detection approaches. This will free up resources for work on more productive activities. There are also wider benefits from strengthening trust in government schemes and demonstrating resilience to new forms of fraud. The costs will mainly be existing civil servant resource because we will be using open source packages and government IT infrastructure. So for the proof of concept, we would need to reprioritize the work of 3 data scientists for 9 months. And once an agile proof of concept has been demonstrated, we will look to scale up with an additional small team who would productionize the toolkit and make it available across government. I will pass over to my colleague, Andrew.
So as Stephen said, what we're going to do is start out with a really small-scale case study and prove that concept, see the limitations that we need to face, and then look to scale that up more widely. And the great news is that there are hundreds of cases that we could potentially apply this to across the civil service, covering those 45 organisations that we mentioned. Fraud is present in a huge amount of different areas. Tax schemes, benefit schemes covering both individuals and businesses, both central and local government as well. So we have a great range of choice. What we're going to focus on initially is on support schemes. And for context, in 2019-20, support schemes cost a combined total of £118 billion just for that single year. Within support schemes, what we're going to focus on is a VAT scheme within HMRC. And we've already had initial verbal approval for us to use this concept for that scheme. But we've also had productive conversations with other schemes, such as the Bounce Back Loan Scheme and the Self-Employment Income Support Scheme. Just for context, that VAT scheme alone in its lifetime will cost the government £10 billion. So just imagine what that one isolated case study could potentially uncover in terms of hidden fraud. So to summarise, the scale of fraud is huge in the public sector, and it is not a victimless crime. It covers a huge range of organisations and a huge number of civil servants. Our unique tool can help support these civil servants, support these departments, and reclaim potentially hundreds of millions of pounds, which could be better used to support the government's priorities. We will do this using a small-scale case study, testing the proof of concept with a view to then growing it more widely. We will do so in a way that is ethical, pointing people in the direction of the right guidance so that people can use these algorithms quickly and effectively, but in a way that makes sense to do so and does not compromise on data security. Very happy to take questions, and thank you for your time.
Thank you, everyone. Really slick presentation there. Appreciate it. Simon, do you want to kick us off with questions?
Hi, team. I'm Simon from the Home Office. So you've done a great job of bringing to life the opportunity from improving how we tackle fraud. What I'd love you to help me get better in my head is how this unique tool can apply to so many different potential fraud use cases. So bring to life for me what this tool could look like and how it works.
Sure. So if I just briefly summarise and then maybe look to bring others in. So what we will do is collate together a collection of algorithms and potential models that people can use, counter-fraud analysts can use. And these are cutting-edge tools, some that have recently been developed in just the last 2 or 3 years. And what we'll do is we'll go and apply this to a specific scheme. So if you imagine counter-fraud analysts are there in government with data, and they have a collection of fraudulent cases, non-fraudulent cases. Ideally, we would be embedded within that team. The data scientists would be embedded in our team, and use those tools to test their use. But we don't actually need to see the data itself to be able to apply them. And then we would validate that in the team and prove that concept. But I don't know, Emdad, whether you wanted to expand on that at all.
Yeah, so I think of it as a toddler's toy. So if you look at a toddler's toy, we're trying to match patterns and fit into square boxes or circle boxes. Once we identify the pattern in a particular scheme, we're able to apply the same patterns that we know that's fraudulent in, let's say, VAT for sports scheme, in, for example, an SA scheme or a DW scheme. Those fraudulent patterns should be identical or similar. If they're not fraudulent, we should be able to diagnose, saying, actually, for our case, that is useful or safe. So that gives us a better history or understanding of schemes and these patterns, that how we apply to them. Hope that helps.
Okay, thank you.
Can I ask a quick question about what happens if the tool is really successful and you find a lot of this unknown fraud? Part of the challenge is there is a limited amount of resource across government that can actually handle the interventions. So just tell me a little bit about how you see that working if this idea is successful and you do uncover fraud that wasn't seen before.
So the fraud that we will uncover is fraud that there are two kind of mechanisms. One is kind of preventative fraud, and then the other side is in being able to reclaim fraud. So, and the benefit of this approach is that it can tackle both those areas. So if you imagine setting up a scheme where you've got a new flood of claims coming in, these algorithms can be applied to those new claims, better categorize more accurately fraud, which means that there's less of a caseload that will have to go to manual review. So that's the preventative approach, and that's about trust, strengthening trust and resilience. But on the reclaim side, there's already a huge amount of fraud, which has already gone on. And so, and government analysts have a large kind of training data set, or historical data set of these claims. And as you saw in the slide, the vast majority of this fraud has just been processed and people don't even know about it, that it exists. So our new algorithms will be able to get into that hidden fraud and potentially then lead to those claims being reclaimed. But I don't know if others wanted to come in.
Yeah, if I might add, I think another part of it is to sort of categorize in a way high yield, high risk, depending, we want to have a deterrent effect as well. But at the same time, having high yield, low sort of impact effect to resolve the case, such as that we can still get the yield, which sort of generates revenues for the government to invest somewhere else.
Thank you. Arjun?
Thank you. Thanks, guys. I thought that was excellent. Can I just try and bring it to life, so see if I've understood it? So essentially what you're saying is this fraud DNA is almost like a pattern that you could then apply in different ways. So for example, if you have a business that had 3 different resets of their account, has got no employees working for it, or whatever risk rules you've got, then generally this pattern we would recommend as a preventative pattern to stop anything happening, i.e., just stop it before the fraud happens. There might be another pattern that you say this will be a lead. So essentially this is what we're developing, these patterns or algorithms that then you organisations can use, depending on, you know, the operational thresholds they have for something, to stop it at source, stop the kind of activity, or do something retrospectively. Is that broadly what we're talking about?
Yeah, that's right. So we would go to a scheme and we would say, try these various algorithms. And with the data that you've got, let's say you've got counter fraud analysts might have name, address, postcode, and other such information. Our algorithms would detect hidden fraud in that. And it's in the slide you see it's all about networks, about graphs. And those graphs can have patterns to them. It might be that a node is connected to 5 other nodes, connected to one influential player. And it's that pattern which is the key. And these 45 organizations often have the same data. They just don't necessarily share that data. So we could successfully see fraud in a data set that has name, address, and postcode. And we could apply it to another scheme where the data owners also have name, address, and postcode. We don't have to link the data together. We don't have to bring the data together. We just say, have a look at these patterns. Try these algorithms. Try these parameters. Try these patterns, and see if it applies to you. So in a way, we're a step removed from the core data.
Yes. And I think the thing that distinguishes what we're doing here, apart from what exists already within HMRC, say within RIS or within DWP, is that you've got the benefit of looking for these patterns across a broader data set, and it's a more generic pattern that can apply in different use cases, basically. So those same patterns may exist within HMRC, but that just validates the pattern in a sense, because that same pattern could be applicable within DWP.
Correct.
Got it.
Correct.
Thank you.
Alison?
Hi, team. Alison from ONS, and we're all talking about counter fraud and how to use data science. It's great to see this particular use case come up and well presented. I think the conversation's been helpful because initially I was thinking, well, why is it a toolkit rather than just attaching algorithms to the systems? And I think Aidan's helpfully talked through the fact that this is reproducible and it moves and it learns in its own right. So it's not a toolkit necessarily for the user, it's a toolkit for the algorithm to improve itself. So that all makes sense. Which leads me to a question really, how well does this complement government's ambition to tackle counter fraud then? Because it is one of our biggest topics. And when you mention the 3 data scientists, it sounds, well, that's quite small compared with government's intent here. So do you know how these things come together? And my question would be, if it was more than 3 data scientists, what would a scaled up version of this look like then if it was commensurate with government's intent?
Should I say, so initially we're obviously aware that there is a counter fraud sort of profession that we sort of are linking into, and the sort of 3 data science thing is that proof of concept specific. It's almost like a specific project rather than the entire scaled up version. So we think that what we want is that proof of concept so it becomes more real to people first, and then that's when it can start to grow and develop with that intent. And we see cases such as the Public Sector Fraud Authority where they are focused on this data. So what we'd be wanting to do throughout the development is speak to them and ensure that we are coordinating both with the profession and the specific organisations. I think, Stephen, if you want to talk a little bit more about the scale-up?
Yes, so we would expect once the proof of concept has been demonstrated for the small team that would productionize it to be slightly larger, and then we would also need a similar sized team to maintain the system.
Yeah, just to comment on that. So I think the way I could see it is you've got this team, you've got a large number of civil servants who are investigating fraud, and what our approach would be to take the most advanced algorithms and analytics, introduce them and embed them in a scheme, and then if they're successful, they're obviously going to need to be maintained. So there's an element of training and handing over of those algorithms into a more of a production environment so that team can then run and monitor and use those algorithms themselves. So as we scale it up to more departments and more schemes, the number of people using it is going to grow, and so the resource attached to using advanced analytics is also going to grow. But we feel like that smaller team moving from scheme to scheme and taking the kind of learning there and applying it is the approach. It kind of gives us a degree of agility, and again, key is the proof of concept. And the good news is that we've got some tangible KPIs or metrics that come with this. We can detect hidden fraud and say we've saved X million pounds, or X million pounds that people didn't know about a fraud is now visible to people. So that's something that I think we're keen to kind of emphasise when we're doing these case studies. Put pounds to them.
So if you're successful to the next phase, having that really clear sponsorship from the function would be really valuable, because you're quite cheap in terms of 3 data scientists for incredible tooling. Yeah. So getting that loud and clear from them, they should be chomping at the bit, and you need to capture that to have that drive.
Yeah.
Sue?
Yeah. Hi everybody. I'm Sue, and just to pick up, we can probably introduce you to colleagues who head up that function. There's an observation on what you've just been saying. So that kind of rollout stage, it's worth, if you haven't already come across it, chatting to colleagues in OSR who've taken on responsibility for the reproducible analytical pipeline, RAP as we call it, because that's exactly how that started back 5 or 6 years ago. It was 2 data scientists in GDS who had an idea about, from their experiences being statisticians in a department that won't be named, and that was the gradual rollout. There's a big, as well as the exciting stuff that you've mentioned, Aiden, around the potential reproducible patterns, there is an upskilling element. So I was really heartened to hear you, that you've reflected on that already. But go and have a word to those colleagues in OSR, because they'll have the kind of lessons around that there's a blueprint for you.
I don't know if someone wanted to touch on the guidance and the plans for that as well. Gaurav, maybe what?
It's about the overall scale.
Yeah, not just this is not just kind of code and algorithms. There's a whole kind of set of guidance around it as well.
Thanks, Andy. Yeah, it's the way we looked at it. It's that although the toolkit sort of makes it easy for individuals to interact with it, the way to build it is to also consider the biases which might come across with it, and also to build, and this proof of concept going to be a learning pattern there, and to make sure we root out any issues we see early on, and then we go further on to different scheme or different department, we'll be able to take that challenge head on and sort of be prepared for it. And also there's going to be ethical side of this, and where we have to consider how to root out which algorithm going to be better for one problem might not be good enough for the other. So to understand that, and we also thought about it sort of coming from our own line of work, where we have to sort of comply with each department's regulation on the data protections and what's the policy, how the data can be used. And so yeah, those are the challenges we've been thinking about, and I think that's sort of, there's going to be points where once we've done the proof of concept, because we're not going to be sort of taking any intervention as such at the beginning, but when we go to the stage of intervention, we'll need to take a look into the policy side. The combination of using that data in such a manner, is that a correct way to go, or do we need to look otherwise? Even if we go for intervention, and if someone challenges our approach, we lose out a very good way to go forward. Thanks.
One of the questions we're asking all of the teams is, if you do get through to the finals, what we can expect to see as judges?
That's a good question. So I think there's going to be more on the particular case studies. So I think between now and the final, we will have talked to a lot more people. It's been 8 weeks, and we have talked to people in the Cabinet Office, in HMRC, but we would like to talk to as many of those 45 organisations as we could, as well as potentially having some really good conversations with the Public Sector Fraud Authority in the profession, in terms of selling this as a concept, and really getting more of their feedback and thoughts on how we could implement it. I think we could go into a little bit more detail on the specifics of the case study as well, and the VAT fraud case study, get some more endorsement there, and potentially talk a little bit more about which algorithms we're talking about, and how this really is, and trying to sell that, how this really is truly innovative. Okay. But yeah, I don't know if
I think we would also kind of hope to be able to present a full prototype of the interface, because we would also want to kind of demonstrate not just the model building that NDAD did, but also the kind of tool diagnostics and comparing algorithms as well, and show how we want to build a community around this toolkit.
Perfect.
Why-
And one final question from Henry.
Why can't you have identified some fraud by the final?
I'll take that one. I think
I don't want conversations. I don't want C models. I want fraud identified.
very valid point. I think
And
from a
prosecuted.
conversation we had with HMRC
Don't worry about that.
on the VAT scheme, when we approached it, it was for a specific scheme, but their keen interest is to apply it as a test run on the whole VAT repayment side, where we get the claims for people asking money us back, some genuine, some not so much. And so our objective is to sort of start the process to apply, because we've given a green light to do it. But in terms of development process, it's just going to be few people at the beginning to building up. We could probably come up with a scale on a small set, but we can't say that given the timeline or the resources.
I believe in you. I believe in yourself. Because I think what's exciting about your doing is that it's, and I did get very confused at the beginning, because I thought it was like the toolkit concept confused me, because it seemed like a kind of self-serve thing for people to use internally, and when I saw people clicking on things, that I found that difficult. That might be me being stupid, but you might want to rethink that, the way you kind of describe it. When you then said, well, actually this is like kind of almost crack teams going into departments and like helping them like do the action. I mean, the truth is the departments should be doing this already themselves, right? Like this is what all of these the data people in these departments should be doing. So you guys showing how it's done and then like getting everybody to do it would be great. But I think to like see real movement of like having built a prototype and also run some data through it, or even dummy data or whatever it might be, like I think that would be really super impressive.
Yeah, I think it's the work of the counter fraud function is incredibly important, and investment in that can often generate hundreds of times a return on that investment in terms of reclaiming fraud back. So the way in which fraud is currently investigated is effective, but only for certain types of fraud. And we've identified this hidden fraud, which we think the most advanced analytics is really going to crack and shine a light on. And we're really confident that approach of agility, moving around the function in a combination with the traditional approaches is the best way. And with your backing, let's see what we can do in March in terms of turning that into some pounds. So yeah, it's a very good challenge.
Good close, very Dragon's Den. On that note, great job team. Thank you very much.